Good. So we shall start with the next segment. The next segment that we have is mechanism of breathing. We'll just give a quick recap of what we have discussed so far. So far, the concepts that we have covered in the breathing and exchange of gases. So we have seen the meaning of breathing. Right? We have seen the meaning of breathing, simply the ventilation or the pulmonary ventilation, and then the organs of breathing. Right? Then the organs of breathing have also been discussed. Right? In the animal world, what kinds of organs are there? In the human respiratory system. So in this we have seen the conducting part, and the respiratory part. Yes. What does conducting part includes? What does it includes? Right? So it begins with the nose. Right? So we have nostrils in here. Yes, nostrils. Nostrils opens into nasal cavity. Right? Nostrils opens into nasal cavity. Nasal cavity opens into pharynx. Pharynx into larynx. Larynx into trachea. Right? So trachea gets divided into bronchi. Right? Bronchi into bronchioles. Right? So in the bronchi we have primary, secondary, tertiary. It's bronchi by bronchioles. In the bronchioles we have primary, secondary and tertiary bronchioles. Right? So begins with the nose, nostrils, nasal cavity, pharynx, larynx, trachea, bronchi. So this one is the bronchi, bronchioles into primary, secondary, tertiary. Up to this level, it is called as the conducting part. Respiratory part, what does it includes? So it includes the respiratory bronchioles. What is this respiratory bronchioles? These are still thinner bronchioles. Respiratory bronchioles. Then we have the alveoli, where the actual site of exchange is there, because alveoli contains the exchange membrane. That's where the exchange will happen. Right? This is all the things that we have seen yesterday, and brief details also we have considered. And to continue with the today's lesson. Yes, today what you're going to be doing here. So what we shall be doing here is, so I have taken up a model diagram here to explain the process of mechanism of breathing. Right? What happens? So we have two processes, inspiration, expiration. So breathing, how does it happen? So breathing is also called as pulmonary ventilation. Right? So breathing is also called as ventilation. I have explained this in the introductory lesson. We have seen how the breathing is called as the ventilation, and since the ventilation is happening in the lungs, it is called as the pulmonary ventilation. And we have also seen the structure of lungs as well, and we will see how this happens. So this breathing involves two processes. It involves two processes. It involves two processes. What are those? One is the inspiration, or we can call it as inhalation. Inspiration is alternatively by other name is called as the inhalation. And the next one that we have is the expiration. The expiration, or alternatively you can call this process as exhalation. So it is the exhalation. What happens in the inspiration? What happens in the inspiration is the air is drawn in. That means the air is allowed into the lungs. By the process of inspiration. In the expiration, what is happening? The air is expelled out. Right? The inspiration, the air is drawn in, and in the expiration, the air is expelled out. Two processes involved with the alternative names also that we have seen. And how is that possible? How are you able to draw the air into the lungs? How are we able to expel the air out? So what is the process that is involved here? What is the mechanism? So this primarily will happen due to pressure gradients. So it happens due to pressure gradients, or simply you can call them as pressure differences. Pressure differences between what? Right? So where is this pressure differences are occurring? These pressure differences are measured against the atmospheric pressure. Right? It is measured against the atmospheric pressure. So atmosphere has some pressure because of the presence of all these gases, right? So these gases will exert some pressure in the atmosphere. Now this pressure has to be measured against the atmospheric pressure. So since here lungs are involved, we are measuring the pressure in the lungs with the atmospheric pressure, right? The pressure that is generated in the lungs against this atmospheric pressure. How is that pressure created in the lungs? We're going to see in a short while how is this pressure, either negative pressure or the positive pressure, how this pressure is created and what kinds of systems involved here. We will do that in shortly. And now, so obviously you are comparing pressure that is there in the lungs with the pressure that is there in the atmospheric pressure, right? So if very important point, please do note it down. If in lungs, right, the pressure is negative to what? Negative to atmospheric pressure, right? If in the lungs the pressure is negative, very important statement. If in lungs the pressure is negative, then you compare with the atmospheric pressure. The basic principle here, negative when it comes to the atmospheric pressure, then what happens? The inspiration will happen. And how will there be negative pressure? We're going to see about that. The inspiration will happen, and if it is positive, right? Positive, what does that mean? The pressure is more here in the lungs. Compared with the atmospheric pressure, right? Compared with the atmospheric pressure. So then what happens? Is the expiration. So if it is negative pressure, inspiration is happening, all the air is taken in, and if it is positive pressure, expiration is happening. If it is positive pressure, expiration is happening as a result of it, all the air is expelled out of the lungs, right? And how does that happen? In the lungs? So what kind of anatomical setup is there? In the lungs to facilitate the creation of these pressure gradients? To creation of negative pressure gradient or the positive pressure gradient. So what is happening here? So we shall see that now. So if you see, yesterday we have seen the anatomical setup of lungs. The anatomy of lungs. That in the anatomy of lungs we have seen, right? We have seen dorsally. What do they have? They have the vertebral column. Dorsally, you can see that here. So this is a dorsal representation for us. So this is actually the dorsal side, and this is actually the ventral side. This is a representation diagram that has been presented in the NCERT. Now, dorsally, vertebral column, and ventral side, what we have? Ventral side, you can see that ventrally we have this sternum. Right? Ventrally we have sternum. Laterally, what we have? So laterally we have the ribs. Laterally we have the ribs, and posteriorly we have the diaphragm. Anteriorly we can say the the collarbones. So the lungs go as high as this collarbones, such as clavicle. Yes, so this is the anatomical setup. Where are the lungs are present? Lungs are present in thoracic cavity. Right? Lungs are present in thoracic cavity, and lungs are housed in this cavity. Do lungs have any muscles? To facilitate the breathing mechanism? As a matter of fact, lungs do not have any muscles. Lungs do not have muscles. Then how is the breathing is achieved? If you see, the lungs have pleura, right? The lungs are protected by the pleura. This pleura has two layers. Yes, this pleura has two layers. Yesterday we have seen one is the parietal, right? So one is the parietal pleural layer, and then we have the visceral pleural layer. Parietal pleural layer and visceral pleural membrane layer. Now this parietal is attached with the thoracic cavity, right? It is completely attached to the thoracic cavity, and visceral it is attached with the lung surface, right? It is attached with the lung surface, and we have the fluid between these two. And when you say this intrapulmonary pressure, you are actually considering the pressure that has been created here between these two layers, right? Intrapulmonary pressure, right? So when you say the pressure that is created in the lungs, it is called as intrapulmonary pressure, or you can say, as a matter of fact, intrapleural pressure. So this pressure can be called as the intrapleural pressure. So both are same, right? Actually, the pressure that is created is between the parietal and visceral layers. So what does that mean here is, whenever there are changes, in the size of the thoracic cavity, if whenever there are changes in the thoracic cavity, and these changes will be reflected in the pulmonary cavity, right? These changes will be reflected in the pulmonary cavity despite not having those muscles. That is how the breathing is facilitated in the lungs, right? That's why the breathing is facilitated in the lungs, because the pressure differences will happen inside the lungs. So that is called as this intrapulmonary pressure and intrapleural pressure. So what muscles are involved here, right? So what muscles are involved that are working on this thoracic cavity, right? So they are not working on the pulmonary cavity, thoracic cavity. If there are changes in the thoracic cavity, obviously those changes will be reflected in the pulmonary cavity, so that the pressure gradients will be created, right? The muscles, what kind of muscles that we have? We have the muscles, right? Two important sorts of muscles will be there. One is the diaphragm muscles. The diaphragm muscles, these muscles are also called as phrenic muscles or radial muscles also we call them, right? Phrenic muscles are the radial muscles. And then we have the costal muscles, because they are present between the ribs, right? So in here, these are the ribs that we have here. Yes, these are the ribs, and the muscles that are present in between the ribs is called as the costal muscles. So here the costal muscles, two kinds of costal muscles are there, right? So costal muscles are simply, or we can call them as intercostal. So why are we calling them as intercostal here is because they are present between the ribs. So I'll just write intercostal, right? Intercostal muscles. So there are external intercostal muscles, and then we have the internal intercostal muscles. Two kinds of muscles are there, and these three sorts of muscles, right? These three types of muscles. As a matter of fact, two, right? So two comes here. So we have further divided them. So diaphragm muscles alternatively is called as phrenic muscles, and costal muscles alternatively is called as the external muscles, and the internal intercostal muscles and external intercostal muscles. Yes, that is the scheme here. And what we have tried to understand here is how the anatomical arrangement of lungs, right? So how this anatomical arrangement of lungs is facilitating the process of inspiration and expiration, right? Because the lungs are housed in the thoracic cavity. What are the changes that are taking place in the thoracic cavity will be reflected in the pulmonary cavity. Pulmonary cavity is nothing but the lung cavity. Lungs do not have any muscles, and thoracic cavity have the muscles, right? And what are the changes that are there in the thoracic cavity will be reflected in the pulmonary cavity. And we have seen how this thoracic cavity, as a matter of fact, all of this arrangement is for the thoracic cavity. Thoracic cavity dorsally is lined by vertebral column, ventrally by sternum, laterally by ribs, posteriorly by diaphragm, and anteriorly by this collarbone clavicle. Yes, so that is the setup. And what are the muscles here? Muscles in this setup. The muscles are diaphragm, phrenic muscles, intercostal muscles, external and internal intercostal muscles, and all these will help in the creation of so-called pressure gradients. Just now we have seen. Now we actually go into the process of inspiration and expiration now. So what happens and what muscles will play a role in the inspiration and expiration? Please do remember these two sets of muscles. Okay. Now, which is first? So the breathing, which process happens first? Is it inspiration or is it expiration? Right? So the breathing The breathing, the first step is inspiration, then expiration will come. Right? So the breathing is inspiration. So how is this happening? It is initiated. Inspiration. It is also very important NEET question. Right? Inspiration is initiated by what? Inspiration is initiated by what? So this is an important question. So please do remember it. Inspiration is initiated by what? It is initiated by phrenic. I'll just write diaphragm here because so it's there in the diagram. You will know it. So please follow this diagram. Diagram. Now diaphragm. What muscles does it have? Phrenic muscles. And it is initiated by diaphragm. Inspiration is an active process because there is involvement of energy here, right? There is involvement of energy. Why there is involvement of energy? It uses up the energy to contract diaphragm. To contract the diaphragm. So as an initiation, the contraction, right? So the contraction of diaphragm will happen. The contraction of diaphragm. When the contraction of diaphragm is the first step. As a result of that, what happens is diaphragm normally is in the shape of a dome. Right? You are seeing when it is relaxed. Right? Diaphragm normally is in the shape of a dome. Dome shaped one. Right? As a result of this contraction, it attains flattened shape. Right? So it gets flattened here. So it is the dome here. So when it has contracted, as a result of that, now it is flattened. What does that mean here is now the size has increased in this vertical axis, right? The size has increased in this vertical or antero-posterior axis. Antero-posterior axis. Right? The size has increased in vertical and antero-posterior axis, right? So in this direction. That is antero-posterior axis, right? So from upwards, in this vertical axis. That is antero-posterior axis in this direction. In this direction, it has increased. That is step 1. The contraction of the diaphragm is the first step. And the second step that we have, right? So second step is contraction of external intercostal muscles. External intercostal muscles. Right? External intercostal muscles. So what kind of muscles? External intercostal muscles. Where are they present? They are present in the ribs. Right? They are present all over the ribs, which are connecting the dorsal and ventral side of this rib cage. Right? Rib cage, which is connected to dorsal and ventral side. As a result of that, what happens is, so here the thoracic cavity is lifted. The thoracic cavity is lifted in which direction? Which direction is dorso-ventral axis. If it is anterior posterior axis before vertical axis, this one is dorso-ventral axis, dorsally and ventrally. Immediately they will happen. Right? Dorso-ventral axis, or you can simply say outwards and upwards. Right? That's why. So when you inhale, that's why your chest moves up, right? Chest moves up, moves forwards a bit, a little. Yes. So that is the outwards and inwards. As a result of that, what happened now here in the step one? In the step one, the size has increased in the direction of anterior posterior axis. In the step two, because of the external intercostal muscles, the size has increased. Size has increased as a result of this dorsoventral increasing size in dorsoventral axis. Now, because of the bigger size, a negative pressure, right? Because of the bigger size, a negative pressure has been created in the lungs. In the inspiration, what kind of pressure? A negative pressure. Negative pressure has been created. So that is why all the air that is present in the atmosphere, right? All the air that is present in the atmosphere now rush into the lungs. Now rush into the lungs, and they'll be taken to the alveoli to exchange into the blood, so that it can be taken to the body parts. Yes, that is the inspiration process. And expiration process is easy now. Expiration process is easy, right? All of this is inspiration. And when you take expiration, so when you take expiration, what is happening on these two muscles? So first, the diaphragm relaxes. The diaphragm relaxes. So when it is relaxing, what is happening? So this flat will be dome again, right? So flat diaphragm is converted to dome shape again. Dome shape again. As a result of that, the size has decreased. So the air tries to go out in this direction. You see, we have presented the bigger size here. And we have presented the smaller size here. And why is the smaller size? Because it is pushing that in, and then external intercostal muscles, EIM, external intercostal muscles, they also relax. And as a result of that, so the chest that has been pushed forwards will be coming back to its original position. As a result of that, what happens is size is decreased. As a result of that, what kind of pressure is created here? The pressure that is created is the positive pressure, right? So previously there was negative pressure. Now the sizes have decreased, and a positive pressure has been created, and the air has been expelled out. So that is the breathing process. Inspiration and expiration, one happening simultaneously, one after the other, continuously. How many times does it happen? It happens 12 to 16 times per minute, right? 12 to 16 times per minute, and this is measured by this instrument called as spirometer, right? So this happens by instrument called as spirometer, and this is the involuntary process. We cannot wantedly increases the size of the thoracic cavity. You cannot do that. We cannot make external intercostal muscles to contract. We cannot do that. What can happen is you can increase the strength of breathing. That means you can breathe more number of times. That's what happens when you exercise, when you run, when you forcefully breathe, right? So this is the normal process. As you go about in your daily activities, and this is what happens without even consciously thinking and breathing. So this is the process that keeps happening in the body, that is inspiration and expiration. The important points to be highlighting, and very important and very easy as well, is where the relaxation is happening, where the contraction is happening. Inspiration, contraction, it's an active process. Inspiration, contraction, active process, because all the muscles are involved here and those muscles needs to be pulled, contracted. That is why it's an active process. Expiration, it's a passive process. It's a passive process and it's a relaxation. Let's say, for example, in the expiration, diaphragm, does it contract or relax? It relaxes. Let's say, for example, in the expiration, external intercostal muscles, if I say they contract, obviously it is wrong, right? They relax. So these applied questions, will be asked more from this physiology of the breathing. That's why you got to be very cautious here. And the measuring these 2 points are very important. They keep asking in the exams, right? How many times per minute is? It is 12 to 16 times. And the measurement is coming from the spirometer. Spirometer is the measuring device. So these 2 muscles, right? And we'll also see the forced breathing ones so that we can wrap it up. Hope we are making sense here. Now, the forced breathing. So this is not the normal kind of breathing. This happens in an emergency or extraordinary situation only. You would be forcibly doing that breathing. Normally, our body is used to the amount of air that has to come in. The lungs takes care of it. The body takes care of it. And if in a situation where the body needs excess amount of oxygen, then you will have the forced breathing, especially when you are exercising or running off from a dog or something, right? When you are being chased by a dog, you obviously will have to run. You will have to run, and for the running, you need more of oxygen. In that case, forced breathing. And what muscles? The abdominal muscles. The abdominal muscles and internal intercostal muscles. So here in the forced breathing, what happens is 2 muscles. The inspiration, the air as well comes in, but mostly what happens with these 2 muscles is most of expiration will happen. Kind of, we can say forced expiration. Forced expiration will happen. In this forced expiration, what happens is these abdominal muscles, which are almost right below this diaphragm, try to come forwards, kind of upwards here, not forwards. They try to come upwards and they push against this diaphragm. Making it kind of fully curved, right? Fully dome-shaped curve. Fully curved will happen. As a result of this, this size will further decrease. As a result of this size will further decrease, and in the expiration, in the forced expiration that we are speaking, right? So what is the role of this internal intercostal muscles? We have seen the function of abdominal muscles, and what is the role of this internal intercostal muscles is, so here they are present in the ribs, no? So these ribs will further move the thoracic cavity kind of downwards, like into downwards in the dorsoventral axis. It is further kind of constricts it, pushes it down, and as a result of that, so this size will still more smaller. Will be still more smaller as a result of that. More of this air is expelled out, right? So that is the case with the forced breathing, and all you need to remembering for our need purposes is you need to be remembering these 2 muscles, right? That is abdominal muscles and internal intercostal muscles, and this doesn't have any role in normal breathing process, right? This doesn't have any role in normal breathing process, and those 2 muscles that we have discussed, the phrenic muscles and external intercostal muscles, have a very important role in the breathing process. Okay, so that is the end of lesson for you today. So thank you.